Okay, so today we're going to look at polymorphism, which is a fundamental concept in object-oriented programming. Basically, it allows objects of different classes to be treated as objects of a common superclass. Now, in Java, polymorphism is primarily used in method overriding and interfaces. We're going to have two real-world scenarios of how we can implement polymorphism when dealing with a superclass and a subclass. The concept is similar to what we have been dealing with in classes and inheritance, but the only difference here is that you can only achieve polymorphism through method overriding and interfaces. Let's take a scenario when demonstrating polymorphism with method overriding. Let's say we have two problems here. We want to deal with a typical example. Let's have a look at this example. In this example, we will demonstrate polymorphism using method overriding. And this is one of them. The other one is interface. I'll be able to show you that later. But now we have a superclass with a method calculate area. We shall demonstrate this when calculating the area of a rectangle and the cycle. That overrides methods to calculate their respective shapes. We all know that rectangle is length times width. And also the area of a circle is pi r square. Now, we will try to use method overriding to help us calculate these respective areas of these shapes. We have a rectangle shape and a cycle shape. So let's look at this in our VS Code, in our live demo. So we will get to the VS Code and then look at this in the live demo. Okay, let's pick up in the live demo now and we look at this concept. So I have my VS Code this side here, which basically I'm going to move inside this folder and we will call it, we'll try to call the file in any name that we want, but we need first to open a folder so that our work, okay, just need to open a folder in the desktop. Now we have some folder here which is already open, and now we are inside this folder. Of course, this has maybe a number of typo, but that's not a big thing. Let's create the files. This is just basically checking them out and making sure that they're all good. So we can create now our new file, new, and we can call it polymorphism. I've read it, yeah. I've actually had a typical example here which I looked at, but it's better I rewrite the script for you. So we'll create a new file and call it so I'll call it polymorphism. And I already have some file polymorphism. So I'm just going to put polymorphism 2 dot or I just call it polymorph dot Java. Remember, I already have some file which I created there. Then I'm going to press enter. And I told you that this public class is basically to help us display the run the run output in our console or terminal. We'll first comment this out, then we shall later use it when we are dealing with that concept. So now, in our question, we are interested in calculating the area of a rectangle or shape, but we want to focus our interest in first understanding that polymorphism can work with superclass, and that method can be used to override the superclass to help get the calculation. So how can we get that treated? We shall use our superclass. So our superclass basically is going to be, we can get a class for shape. There are two shapes here. You know, we have the shape for rectangle and cycle. Let's try to treat all of them. So we shall first create the superclass, which is going to be the superclass for shape. Then we shall later have the subclasses for rectangle and the subclass for cycle. But I want us first to start with the first subclass for rectangle, and we see if it can override that to calculate the area of the rectangle. So we shall do public double. Now, why we are using double is that double is more precise when dealing with floating point numbers. Otherwise, we would have used a float. So use double, calculate area. Now, we're going to get the area. Now, in this area, we are only interested in, let's first say it should return, okay, what it should return the value 0.0 and terminate. Now, this basically is going to be, it's going to be the default area of unspecified shape. This will area of unspecified shape. So this is how we can treat the calculation, just to return the area of unspecified shape. Now, we're now going to move to the next subclass, the subclass 1, to get area of actually specified shape, and that is the rectangle. Now, basically, we will create another class for a class rectangle to extend to shape. So this class rectangle extends to the superclass from the subclass to get the shape. Now, here we'll create the subclass. We will create basically what we do, we can try to get the variables where we can say we can make a private double length, then a private double width. Then we can get a public rectangle, then double we can pass in, the double method we can pass in the length, and then double the width. In order for us to get so what basically we are going to do here is that we want to say that this is the length and this is the width, which basically gets the variables for length and width. Now, we need to use what they call method overriding. So here we will apply method overriding to get to actually calculate area of a specified shape. Now we will say then we shall override, then we'll specify and say public double, then we shall say calculate area, and the area we can't specify yet, but we shall use the formula. Shall use the formula return length times time width. So this is going to be the formula to help us get the length, to get the area of the rectangle. Now, what we are going to do right now, in the previous source code, we just need it to display the output. So what we can do right now, we can now uncomment this. Then we shall say public class, then shall use public. You already know to display, you need to use public static void. Void strings args, which basically now is going to be shape. Someone should mute shape one, then new to be rectangle. So we can have, which is okay. Now, what we are going to be interested in here is this shape 1 neo will help us to pass in the value into the method of the rectangle. So here we can say the length can be 10 and the width can be, the width can, okay. The width can be 4. So now we can get the output. We can run the output. We can run the console in console. There was echo, I hope it's off. So how do we do that? It's easier. You already know we can have system out print ln, then it will be area of rectangle shape 1. Instead of saying get area, we didn't say get area. We just said what? Dot calculate area. Yeah. I think we open the bracket. We just need to close the bracket and terminate that. So this will only help us get for the area of a rectangle. We shall later also add in one subclass to get the area of a cycle. So let's try to run this. So the area of a rectangle is 40. And literally, this method override will override the superclass here, calculate area, from this formula that we put to get the calculations of the values that we pass in the shapes to get for us the area of the rectangle. So we could also try to reuse this code to help us get the area of a circle. And how can we do that? Let me check if there are comments in the chat. Kindly, sir, you coming in cuts. Am I coming in cuts? Am I cutting a lot?
Earlier on you were, but now you're clear. Unless others, but me, you're clear.
On my side, you're coming in cuts. I don't know why.
I'm still coming in cuts. Am I coming in cuts? Is my network breaking? Hello?
So you're clear. I think Fabian, maybe something is with the network, unless someone else maybe. Mine is clear.
Okay. That's okay. No, but you will get the recording. The recording can tell whether I'm in cuts or... So this is what you can do to get the area. But now let's try to implement the second. Remember we talked about two shapes. We talked about, okay, that you can use it to calculate area of a rectangle, and then you can use it to calculate area of a circle. But I just demonstrated using what? The area of a rectangle. Within the same code here, let's create another subclass. Then we shall edit. This subclass will be 2. Can I copy this code from here? I can copy this code from here up to, I think up to around here. Yeah. I can copy that code from there up to here. Then I can paste the code there. Now, this time round, the only difference is that since we will be focusing on getting the subclass for what? To get for us the area of a circle, which we will say here, this to get, we are now going to be specific to what? To the shape cycle. All right. Now here we can say, cycle extend to shape. Then instead of calling double length, we all know that we can only calculate cycle basing on what? Area of a cycle is calculated from radius, right? Do you agree with me? The area of a cycle is pi r square. Are you there? I'm seeing the number dropping.
Yes, sir, we're still here.
Okay. And now we can still get and say the public, then here we can say it's still going to be cycle. And now we are going to look at, I told you why we will use double. It's more accurate when precise when dealing with what? Floating points. So we can have radius. Now what you can do here, we can say this radius equals to radius. I think that's much better for the subclass 2. So hopefully we still don't have any error. Then we also need to, in the method overriding, we also need to duplicate that code so that it can override for the subclass 2. So this is going to be for the subclass 2. Remember, this is meant for overriding in the subclass 1. So I can transfer this code it's just a small code. Let me just copy up to, I think, there. Which is going to be for this upper one, for the area. Then this downer one, we can just edit it and say it will override double calculate. Then we are interested here to return, what's the formula of getting the area of a circle? It's pi r square, right? But when you're dealing, we can have the math dot pi to get radius, then times radius. So that's how you treat the pi r square. Is that okay? Then in that way, to get the output, we still need also to implement what? the variables for the circle to get for us the radius of the circle. That means here we can say shape shape 2, which is going to be cycle. So we need now to get the radius, which can be, let's get a radius of 7. Okay. Then we need to get into system dot. So the area of the circle, shape, calculate. Calculate area. Okay. Hopefully we don't have any error. I think we do, saying that we just need to add, maybe we only need to add 1 curly braces. Okay. So this is basically going to show us the area of a circle. So the area of a circle is the 100. So the other 0.0 which we put to get it in terms of the double, which is more precise when dealing with, it brings all, remember it's not good to round off the value to the nearest. So that is how you get to deal with one concept which is called method overriding when dealing with a simple polymorphism concept in Java. The syntax is pretty much simple. I believe you have seen it. And I'll try to put all this source code into the GitHub so that you can pull the source code on your end. But literally, that's how you play around with method overriding when dealing with a simple example like this. So to summarize everything, I'll just give you the explanation in a nutshell that when we have the shapes, we can define it to calculate the area, and then we can return the default values like 0, 0, the way we put it. Then we can create 2 subclasses from the objects. We can create objects of a rectangle and object of, so these are objects of rectangle and object of a circle. Then later, we can treat them as an instance of the common superclass. Okay? Then, if we treat them as an instance of a common superclass, then polymorphism allows us now to call the area, using method overriding for both of the shapes that we use here, the circle and the rectangle. And then eventually they will get the different classes and it will dynamically select the appropriate overridden method at every runtime to display this in our console or our terminal. Now, that's what I feel is okay for us to look at it in that way. Let's first go back to the other context, if you can get another example and try to look at it as a class. So we've done the live demo. I'll share with you the source code. And that has been a little bit much better. So if you have any question on overriding, you let me know. But the next question maybe I have to do in the live demo is probably to give you one more example how to deal with polymorphism through interfaces. But for now, I can unmute, you can unmute, then I take one question using method overriding. Is there any question that I can take using method overriding before we look at polymorphism through interfaces?
Not from me.
Okay, I'll share with you the source code, you look at it. And then you can also replay the video, which I'm going to upload onto the YouTube channel so that you can follow those concepts. Next week, we will be able to start module 3. Not so? We'll be on module 3 next week. Then a week after, the other 2 weeks, we'll still continue learning online. I think it's more favorable for your group. But please try to tell those who miss to go and watch the recordings. It's not good to miss completely. It's not a good thing. Now, we're now going to look at another example of how we can use polymorphism through interfaces, where we will be able to demonstrate polymorphism using interfaces of, let's say we have animal with a method make sound, and then maybe we can look at classes based on dog and cat. Then we implemented the interface with their own sound implementations. This is going to be easier because we will deal with 2 classes and the source code is going to be very small. So we can have poly with interface. So let's just create another script file. Let's look at another live demo with this. So we can look at this basically. Now, we're going to just, I think I can save that. Now we are going to just have the other one with what? Poly. I'm putting poly interfaces dot Java, so that you understand. Always we will use this later, so I'll take it a little bit down. Now I'm going to explain how we create the objects and then later try to move with it, okay? So, but what we are going to be interested in is that here we will try to, let's see what we can do. It's basically, let's just make it multi-line. So what we are going to do, this is going to be our example 2. So we're basically going to demonstrate polymorphism using interface. Using interfaces or interface method. So let's try to do this practically. First, we will call this interface. Then in the interface, we can have interface animal. So animal, then we can use void to make sound. Now the voice to make sound is going to be basically the void to make sound is going to be the method that we will use it for the implementation. Then we can create another interface by providing their own make sound. So let's try to do that, but let's first create that using let's create that using the classes. So we are going to have class 1, which basically is, we will say it's a class for, let's pick an animal like dog, implements animal. Remember now, this is different from the way we are doing it. The other one extends animal. This is dog implements animal. Then so we will have the override. So it will override the public make sound. Then system, what you're going to say in the text is dog barks. Is that okay? Then we'll do another class, which is going to be class 2. And we'll say class, let's say cat, then implements animal. Then we will say at override. Then we say public make sound. Then we say system out. Then we say cat. Cat doesn't bark. Cat meow. All right. Now we can now later try to make sound and see how these objects can be implemented using the interface. So we already have this code here. We shall just call it and then uncomment it. Then we will say public static void, of course, public static void. Then we will say animal 1, just animal 1, new, we can say dog, then animal 2, cat. Then basically, instead of doing a system out, since we're dealing with interfaces, we could just say animal 1 make sound, then animal 2 make sound. Okay. Hopefully no errors. Then we can run. So kind of funny that we are getting some error, but we will try to see if there are some serious errors, then we will be able to fix that. So maybe I don't see. Okay, let's just run and see one more time. It's saying, it actually say cut. Okay, let's just check it here. In class, cut implements animal at override public make sound print. Okay. Okay. But everything is pretty much okay. I don't know. Just check interface animal. Okay. Where public make sound. Dog box. Class 2. Okay. Okay. Just wondering why it's not the stop cut. Is there anything that is making it not run? Let's try this. Okay. All right. So I think we don't have any issue with the code. There's literally nothing. But here what it's trying to say is just trying to invoke with the interface method, but it's not, but that's how you really implement the interface method. Let me just explain this. What it does here is that the animal, in this example, basically what we're trying to see is that the animal makes sound. We have the interface animal defines make sound with the method void, okay, with make sound method. And then without any implementation, so here what you have is that the dog and the cat classes, we have the dog class and the cat class. This dog class and the cat class implements with animal, providing their own make sound method. Providing their own, so this is how they're providing their own make sound method, like dog barks, cat. So that's what we're trying to implement. Then later here, what you're saying, we decided to create object dog and treat them as instances of animals. So we created object dog and then treated them as instances of animal interface. So this is what we did, created object dog and object cat, and then we treated them as instances of the animal. Then later here, what polymorphism is trying to do, polymorphism allows us to call the make. It allows us to call the make sound. So we're trying to call the make sound of animal 1, which is a dog, and animal 2, which is a cat. And then later, from this animal 1 and animal 2, which are objects, then they offer the different classes, which later is chosen to be the best of the actual object at their different runtimes. So that's how you treat the concept of polymorphism. Now let's try to look at one other concept that we can explain, then we'll be able to have this concept covered. We'll try this out, but sometimes here is just a challenge with the invoke. It's not even throwing any error, but of course that is how it's just saying it's unable to initialize. That's not the reason. Let me just clear that. Yeah. So the poly main reason type cat current frame start time is not assignable to animals. Okay. Basically that, okay. That's not an issue, but the concept is clear. Let's now try to look at one concept called encapsulation. Let's look at another concept called encapsulation. Now here, with encapsulation, we'll later look at one more example with encapsulations on about the persons. Now, encapsulation is basically one of the 4 fundamental principles that we are trying to look at in object-oriented programming. And we're trying to look at one main fundamental principle, which is okay, the main principle of object-oriented programming that we are looking at, encapsulation, is that it basically refers to the concept of bundling of data attributes. Remember attributes, we talked about it in terms of attributes, we refer them in terms of what I can call fields, and the method that operates on that data in a single unit, which is also known as a class. But additionally, what I can say is that encapsulation restricts direct access to some of an object components. by providing control over the state and behavior of this, the state and behavior of these objects. Let's try to look at this in an example. Let's say in this example, we will create a person with class, we will create a person class with private attributes name, age, and email. And then public getter and setter method to access and modify attributes in a controlled manner. So that's what we want to try to do with this. Then later, we'll try to run this to see if we can update a person's email or update a person's age. So what we will do, as I'm explaining for you, is that we will only have the person class that will encapsulate attributes like name, age, and email by making them private. Then we shall use the get name, get age, and get email to allow control access to these attributes. So the setter name, setter age, and setter email will provide control modification of the attributes with the validation for the age to ensure that it's not negative. So that is basically, we will only look at one method of encapsulation, then we shall look at abstraction. And we will call it a day. So I see the numbers dropping, but I hope you persist. Now let's create a script. Let's just create basically a script here. Then from the script, let's call this encapsulation. I'm just going to call it encaps.java. So we can first comment this, then create the classes. Now, let's first create a class for person, and we are interested in looking at their private attributes. So the private attributes here are that we'll have the private string for name. What string means is it stores alphanumeric character. Then we can use private integer, int, for age, and then private string for email. To this point, you now know that we can have the variables or the constructors. So let's have the constructors. So we'll have public person. Then inside we'll pass the string for name, then age and integer. Of course, this one we have done it a number of times, so it's easier. Then you say this name is that, then this age is that, then this. Yeah, basically to get these constructors. Now, we will then use the getter methods So it will be public string, which is going to be get, basically to return name. Then we will also do it in a similar way to get it for age. So remember, we have done it for name, public, get, age, then return age. Then we will also have it for public, get email, then return email. Now let's deal with the setters. So for the setters, what we will do, we'll create the setter methods. So the setter method would be public, void, okay. Then we will say this name. Then for age, what you could do is to get public, then we set age to get if, basically we'll try to get the age. If age is greater 0, then this age is age. Then else so else then you can get system out. So we can say age cannot be negative. That is if you're trying to put a value which is less. Age must be greater than 0. That's what we're trying to implement. Okay? Your age cannot be 0 point something. Age starts from 1. You're 1 year old and above. Then you can also do let's see. You can also do the public set email. Then you can say this email. So basically that is okay with email. Now, let us try to use this encaps method to see if we can try to have some bit of modification on age. So literally we have the set for set name, the set name, age. Now let's try to make the main function from the class. We can now do public void, then main string args, we close the bracket. Okay. Now what we're going to do is basically to look at, we'll try to create a person's, let's try accessing some of those attributes probably. But first, let's create a person with an email and with some age, name, and some information about the person. So we can say person, then new person. Basically, what we are going to pass here is that maybe the person is Jeff Jove, and then we put a comma, then we put maybe the age, then we try to put the email also. Okay. Now let's try to access that person's information. Okay. Let's try to access that. Access the attributes using the getter method. So now here what we're going to do, I will do system out, then we will say we will try to access for name, person gets name. Of course, you have to terminate that. Then the get has to be a get method. Then we can also do system, then also system dot out get age. Now let's try to modify the person's information. Modify attributes using the setter method. So we can say person, set person, then here we shall say person. This may not be right. We just set age. Then we try to say the person is for maybe 33 years. Okay. Then we can try to update the email person dot email set email. Then we can try to update that email. I put Jeff Jove, so I can say maybe is this time around we are trying to change maybe Justin Oluka at gmail.com. Luca at gmail.com. Okay. Now let's try to update this information and see if this can run for us in the terminal. So display the updated attributes in the terminal or console. So you just still do system out, then updated attributes. Yeah, then you can close and terminate. So here what we want to do is to get the edge, get edge, then the next one also to system dot out, get the email. So we want to see if it would get this last information that we updated, but we still have two more errors here, which is saying that we haven't closed. So I don't know what we need to do here. Okay. We just need to confirm that we have done all the closing, especially on this. Let's just double check that we have done all the closing, because it doesn't make sense if we have not. So let's start with the first one, which is for person. We have the bracket. Okay. Then with the constructor. So let's try to remove this. Okay. Then I think the last one is which one? Let's check it out. It will complain, then we shall see it somewhere here. Okay, so just one, then we can run. We cannot run when the brackets have not been closed. Then the get method. Okay. Setter method. Yeah. I'm not seeing it. Well, it could have. Okay. I think where did we mess up? It can't be here. It's somewhere. Let's just see. Line 66. Line 66. Yeah. It's saying it's in line 66. But you can't do away with this. We need it. Then it's not in line 66. This is line 66, column 1. Supposed to be in there. Oh, this is strange. How about this red one? Okay, I think there's this red one. Okay. Insert this one to complete there. Okay. Okay. So let's try to run. Okay. Unfortunately, it will not be able to show this. Let me just try to see if I can. It will not be able to show this. It won't be able to. It won't be able to show this. It won't be able to show this. Let's just one more time check it out. It doesn't. Okay, let's just try to go through the terminal. Terminal. Run without debugging. So it's basically failing to run. Okay, but exactly that's how you implement it. It's basically not running, but build failed. Do you want to continue? I think so. Okay. Yeah, we shall just continue it. Yeah. So okay, so that's how you implement encapsulation, encaps Java. So this is exactly the output you get when you're running the encapsulation. So I hope that would have helped you understand the basics of encapsulation, which I'll later share with you the source code that you will be able to use. Okay. I'll be able to share with you the source code that you will be able to use. Okay. So that is it for now. I will try to stop this recording here and then share with you the video. So if there's any question, please let me take the questions. The other one which we are going to remain with is going to be abstraction. We can't handle all these three at the same time. Much as has been the coding bit of it, it really takes that much time. So any question from any end about encapsulation, then maybe allow me explain this last bit of it so that probably we could understand it much better for the last bit of it, which is called abstraction. So abstraction generally is one of the four fundamental concepts of object-oriented programming, but it focuses on simplifying complex system and modeling classes to be essential in hiding some of the unnecessary details. Abstractions allows you to define blueprints that represents the common attributes and behavior without specifying every detail. So I want you to look at it into a similar example. Let's say you're going to deal with abstraction, dealing with blueprints. Now, I want to give you this example and explain it how you can approach it. So in this example that I've given you, where you are supposed to create an abstract of a class that defines the common attributes and methods for calculating the area of various shapes. We will also create the concrete subclasses and rectangle that implement the area method according to their respective shapes. You can approach this solution by creating the shape class in an abstract class that defines common attributes like color and attribute an abstract method like area, and then also create the method to display info, like maybe trying to look at the displaying of the colors, the concretes and the subclasses that extend to shape and that provides their own implementations of the area. So in this way, you're able to get what we call the method according to their area shapes. So you could try out this example, but I'm going to do a pre-recorded class tomorrow for the abstraction and then share it with you. So let's take some questions. If there are no questions, then we will have to call it a class, because these concepts are many. Once the recording are ready, I'm going to upload it and then you follow. Then I'm also going to put the source code into the GitHub so that you can also try to practice on your end and see if you can pick up this concept. Any question to this point? Maybe just an overview. Let me just explain now for the last time so that maybe you pick up. When we are dealing with object-oriented programming, okay, we are looking at classes and objects, which we did, inheritance, polymorphism, encapsulations, and abstraction. What is so common here that can be asked is for you maybe to try to explain some of this concept. I'm going to try to get for you some simple examples that you can use for this particular area. Now, what we looked at basically is that we are able to look at classes where we say in Java, classes and objects are fundamental concepts used for creating reusable codes and modeling real-world entities. We looked at an example of modeling a person's entity of name, which we did. Then we also look at inheritance, which is a concept in object-oriented programming that allows you to create new classes derived, which is the derived class or a child class based on the existing classes, the base or the parent classes. Then we also looked at this one last bit of it, which is also in what? Which is also in Java. We look at inheritance to get some of the common keywords. Okay. Now, there's another thing that I also wanted you to understand is that we're able to look at polymorphism, which is basically the concepts of looking at object-oriented programming and allowing you to define different classes to be treated as objects of the common superclass. In Java, which we said it's achieved by what we call method overriding and interfaces. We were able to look at that example in real life. Then we also looked at demonstrating how we can calculate area using polymorphism. We also did some encapsulation, which we were trying to treat bundling of data to see a person's attributes and how they operate. And then we're also able to look at how we can provide control to behavior, how we can modify some of those shapes. Then we also looked at abstractions, which basically we explained abstraction, where we said is one of the 4 fundamental principles of object-oriented programming that focuses on simplifying complex systems by modeling the classes based on their characteristics while hiding the necessary details. And we say that we can also try to look at abstraction that allows you to define blueprints that represents common attributes and behavior of objects without specifying every detail. Now, we also say that we could look at abstraction through creating an abstract of different classes that helps you to calculate like maybe the area of a shape. We can also look at its color. So we can apply that in abstraction. We will look at one more example in a pre-recorded class, which is just a short video. Then I'll demonstrate that, and then I will share with you the link in class tomorrow. So up to this point, allow me stop here so that I can catch up with Jam. But thank you for attending. I'm going to set some quizzes here, then put it in the chat and you try it. I'm going to do it tonight, then you'll try it in the morning. I see if you have picked some of these concepts. Quizzes helps you understand. Is that okay?
Yeah, it's okay. Just a quick one. With the assignment you had left us last week, we did the assignment. When we tried handing it in to the site, you told us it seemed to be a social media site and we failed to understand how to submit it. Maybe you could guide us on how best to submit it in.
Now, let me show you what to do with that site. It's not just a collaboration site. Let me just try to get into my Gmail. I think, okay, let me just get into, I'm just going to log in to get,
And so also, if it's possible, we could have the recording at your earliest.
The recording
because it
is
makes
coming.
us some of us understand it when it is still fresh. We go back and listen to it again.
Okay, I'll make it. And then also I need to share the notes earlier so that you can also follow what you are explaining with that. Because
All right,
I'm sorry, I'm trying to use the programming languages to explain them throughout, which is I know it's somehow may not be easy for someone just landing into it, but yeah. I'm just trying to log in, then I share with you. Okay, maybe I should try to share up to this point. So what you're going to do is that as long as you have your GitHub account signed, then you just log in. Hopefully, it's the same password I have been using. actually logged in today. Okay, never. Let me just get the code from here. It will always try to verify if I am the one. So this is just a collaboration. What? Now, what this does is that when you come to this, okay. I think maybe I need to show you the entire process how to what? How to, so you could just come to this, then you create what? You just have to create a new pull request. No, it's not. Okay. So you can create a new pull request. Then you click on create. No, let's just get back to let me stop this so that it doesn't go. Stop the recording, I mean.